Find a higher order derivative for sine of x. So in this video, we're going to be discussing the higher order derivatives of sine and cosine functions. And we're going to start with sine of x. So we're going to let y equals sine of x. So if we want to take the derivative of y, we have dy dx, and that's going to equal the derivative of sine, which is cosine. Now, if we want to find the second derivative, well, we know to find the second derivative, we're just going to take the derivative of the first derivative, which in this case is cosine. And we know the derivative of cosine happens to be negative sine. All right, well, let's say we want to find the third derivative of sine. Well, to find the third derivative, that means we're just going to take the derivative of the second derivative, which we just found out was negative sine. And the derivative of negative sine is going to be negative cosine. Well, we can continue on going, so let's go one more. Let's find the fourth derivative of sine. So to find the fourth derivative of sine, we're just going to take the derivative of the third derivative, which we found was negative cosine of x. And the derivative of negative cosine of x is going to end up being positive sine of x. Well, isn't that interesting? Because if we start out with sine, and we take the fourth derivative, we wind back up at sine. Well, isn't that a coincidence? So we might be able to say that any higher order derivative where the derivative is a multiple of 4 takes sine back to being sine. Interesting. So basically we're saying if we want to take the derivative, and that derivative happens to be a multiple of 4, such as 4, or the 8th derivative, or the 12th derivative of sine, that's going to take us right back to sine. And yes, that's 100% true. Ooh, 100% 100% true. Because the derivatives, or the higher order derivatives for sine, are cyclical. They repeat the pattern every 4 derivatives. So whenever we take the multiple of 4 of sine, we are going to end up with sine. Well, now let's look at cosine and see if that same pattern happens. So if we come in here and we take the derivative of cosine, we're going to get negative sine. And if we take the second derivative, that means we're going to be taking the derivative of negative sine, which will give us negative cosine. And if we take the third derivative now, we'll take the derivative of the second derivative. So the derivative of negative cosine is going to be sine. All right, well, let's go to the fourth derivative. This will be the important derivative, critical derivative. Will we make it back to cosine? Let's find out. So we'll take the derivative of the third derivative, meaning we'll take the derivative of sine, which is cosine. So yes, it appears as though the higher order derivatives for cosine is also secular, because after taking 4 derivatives, we're back to cosine. So similar to with sine, we can also say that if we're taking a derivative that's a multiple of 4, such as the fourth derivative, the 8th derivative, the 12th derivative of cosine, we're going to get cosine again. And that ends up being convenient when we want to find higher order derivatives of sine and cosine. So let's take a look at an example. So here we want to evaluate the following expression, and that expression is d40 over dx40, so that's the 40th derivative of sine. Well, as it turns out, 40 is a multiple of 4. So therefore, we could go ahead and we could take the derivative 40 times, or by knowing the cyclical pattern, we know the 40th derivative of sine is just going to be sine. Wow, isn't that easy? Well, a lot easier than taking 40 derivatives, so yes. Our next example is we want to find the 35th derivative of sine, find the 35th derivative of 4 sine. Now, sadly, 35 is not a multiple of 4. So, what can we do here? Well, we need to find the closest multiple of 4 to 35 we can without going over. And, as it turns out, 35 is really 32, which is a multiple of 4, plus 3. Now, how is that going to help us? Well, let's take a look. So if we want to actually find the 35th derivative of sine, or excuse me, derivative of 4 sine, what we can really do, since 35 is 32 plus 3, we can go ahead and we can take the 32nd derivative of 4 sine of x, and then we just need to take the derivative 3 more times after that to get up to 35. And now we know that taking the 32nd derivative of 4 sine is going to be easy because 32 is a multiple of 4. So therefore, the 32nd derivative of 4 sine is just going to be 4 sine of x. And then from here, we just need to take the derivative 3 times. So let's go ahead and take the derivative 3 times. So we can take the derivative once, which brings the derivative of 3 down to only 2. And we know we can ignore the coefficient. And then the derivative of sine of x is just going to be cosine of x. All right, well, let's take the derivative again. So that means we're going to go down 1 derivative. Again, we can ignore the coefficient. And the derivative of cosine is going to be negative sine. Well, we can simplify the inside before we take the derivative to get negative 4 sine of x. And then we can actually take the derivative, and we can again ignore the negative 4, and the derivative of sine is cosine of x. So there, we have just found the 35th derivative of 4 sine of x. Let's take a look at another example similar to that. It's just worded differently. So here, we want to evaluate the following expression. And that expression is, we want to take the 13th derivative of negative 2 cosine of x. Well, we could take the derivative 13 times, or we could use our rule of 4s. And for the rule of 4s, we need to find the largest multiple of 4 that goes into 13 without going over. And we can see that 13 is equal to 12 plus 1. So this means to find the 13th derivative, we can take the 12th derivative, and we want to take the 12th derivative because that's a multiple of 4. And then after we do that, we just want to take the derivative one more time. All right, so as always, we know we can ignore the coefficient when we take the derivative of a function. So we'll bring the negative 2 down. And then since 12 is a multiple of 4, we know the 12th derivative of cosine is just going to be cosine. So we're left with negative 2 cosine of x. And then we can go ahead and we can take the derivative one more time. Again, we don't have to worry about the coefficient. And the derivative of cosine is negative sine of x. And then we can just simplify this. Negative times negative is a positive, so we're going to end up with positive 2 sine of x as the 13th derivative. And our final example, we were being asked to find the 97th derivative. Whew, big numbers now, not joking around. So find the 97th derivative of 3 cosine of x at the point x equals pi. All right, so here, we not only need to find the 97th derivative, but then we need to substitute in x equals pi. So we will use our cyclical powers here because I don't want to take the derivative 97 times. So we're looking for the largest multiple of 4 that adds up to 97, and that is 96 plus 1. Which means we'll just take the 96th derivative, which we know is a multiple of 4, so that won't change our function, and then take the derivative one more time. So that means that d97 over dx97 of 3 cosine of x, we can rewrite that as being the 96th derivative of 3 cosine of x, and then we just need to take the derivative one more time after that. All right, again, 96 is a multiple of 4, so that's not going to change our function. So that means we're just going to bring down the 3 times the cosine of x. And now we just need to take the derivative one time to get up to 97. So let's see, we can ignore the 3 because that's a coefficient, and the derivative of cosine we know is negative sine. And then we can simplify this down to have a 97th derivative of negative 3 sine of x. However, we don't want just the 97th derivative, we want the 97th derivative when x equals negative pi. So we need to plug in negative pi for x. So the 97th derivative of 3 cosine of x at x equals negative pi is going to be negative 3 sine of negative pi. And well, we know that sine of negative pi is going to be 0. And negative 3 times 0 is going to be 0. So therefore, our 97th derivative of 3 cosine of x at the point x equals negative pi is 0. All right, folks, that is it. That is finding the higher order derivative for sine.